So today I'm just going to talk about ETH 2.0 and what does ELIF IFP it means explain like I'm fine. So I'm going to simplify what ETH 2.0 is, what it is not, etc. etc. So before we start talking about 2.0, let's just have a recap on what 1.0 was. So basically, this is how the blockchain looked like. There were blocks, in sequence, and every miner was basically participating in a race to, calculate the correct nouns, which will make the block a valid block, and the first one to do it will get rewarded. The benefit of this was that no miner was required to have any ETH to start with, but heavy mining specific equipment was required. So you need to have big and powerful computers that can do the process of calculating the correct amounts in order to make it a valid block. Now the disadvantage of this was that if you have a lot of money, then you can create multiple miners, you can create a mining pool and very easily dominate the mining game. There would be a very high chance that you would be mining a lot of blocks compared to others, which was the problem and which is also against decentralization. So that was Ethereum 1.0, and this is how the snapshot. This is a snapshot of a block which was mined in 1.0. So you can see who mined it, what was the block reward, Uncle's reward, difficulty, etc. etc. These are all ETH 1.0 related terms which do not exist today. So let's briefly introduce 2.0. So this was how the 1.0 chain looked like, and this is how the beacon chain looked like. Now, this was a chain which was running parallel since 1st December 2020, and instead of blocks, it uses something called slots. We are going to explore more what a slot is, and basically, beacon slots weren't associated with um, the ETH 1.0 chain until the merge actually happened on 15th September, and that was also my birthday. So, yeah, pretty good birthday gift. But this is how. This is a snapshot of a slot which was pre-merge. So a slot which does not have any information about transactions or 1.0, and you can also check this online. If we go to the browser, we can see this slot. This is one random slot which was pre-merge. So this was before 15 September 2022, and this is how the block looked like. Slot looked like. It does not have any transactions. However, there was some information related to votes and attestations. What is all this? We will explore this further in the slides. But basically, that's how a slot looks like. And what was the responsibilities of this beacon chain? Why was it made, and why is there a separate chain running parallel to ETH 1.0 chain? So the POS that people say that Ethereum is proof of stake now. The reason why it is proof of stake is this beacon chain is how it operated was. The beacon chain was the POS chain, and it is responsible for like storing all the information related to consensus. Also, the clients of this chain were responsible for calculating and aggregating votes and all of that things. Detecting validator stake and managing validator stake was also one of the responsibilities of this beacon chain. So whenever someone stakes on the Ethereum 2.0 contract, the responsibility of the beacon chain was to like detect it and then add them to a queue. Then they go into various states, which could be pending, or they are active, or they could be exiting as well. Then reward and slashing is also responsibility of beacon chain. So whom to reward based on who is the block proposer, and whom to slash based on whether they are correctly voting or validating or not. One more responsibility was generating random numbers. Why was this a responsibility? We will check why generating random numbers is a thing. But the name beacon chain actually comes from a beacon who generates a random number. That's why it's called beacon chain. And the other thing was finality. How is finality defined? We will explore that in the upcoming slides. So beacon chain. instead of blocks, we can chain as slots, and we can see a slot is 12 seconds. So every 12 seconds, a slot be will come into existence, and what does a slot comprise? Right? What does a slot hold? One thing that it holds is who is the block proposer of that slot, and voting committees. So what happens is a random number is generated for every slot, and based on that random number, the validators, the existing pool of validators, are distributed into committees. Small committees for each slot, and a validator in one slot probably isn't a part of the committee of some other slot in the same epoch. And we will see what a epoch is. And out of these committees, there could be multiple committees, but one committee should have 128 validators. So that was one of the things that we decided. And out of those validators in a single committee, a few of them were selected as aggregators. So they take votes from others and aggregate them, and basically compress that information so that it takes less space. And we can see how that looks like actually. So if we go to a slot, let's say this one, we can see the attestations, and the aggregation bit, this work is done by the aggregators. And these are the validators that were selected in the committee. They could be in the same committee, they could be in different committees, because there could be multiple committees for every slot. And yeah, we can block root, and then the source and target is something that we'll discuss later. And we also have transactions. So this transaction was not a part of this, because this slot is pre-merged, so there was no such thing as like the part of merge was basically when the slot started getting transaction information was when the actual merge happened. That's the difference between POW and POX. When the beacon chain started getting information of transactions. But before the merge, there was no such information transferred to the beacon chain. Moving on. So that was one slot, and 32 slots make up one epoch. So every 12 seconds is one slot, so 32 slots is approximately 6.4 minutes, and we can see that as well. Let's go to the Explorer here. If we, let's see if the internet works. So we can see here that the epoch right now is going on. It's 221,000 something, and out of 32, 24 slots are left to be for this epoch to be completed. We can see this information. And every 12 seconds, this number will keep on decreasing until it's 0, and then a new epoch will start. So that's an epoch, and then there is this concept of checkpoint slot. So checkpoint slot basically means which was the first slot for this epoch. Which slot defines the start of an epoch. That's what people vote on, and we can check that as well on the beacon chain. So if we go to this slot, this epoch actually slot, and if you go to attestations, we can see here the source and target. So basically, people are saying that this block belongs to this source, which is the actual epoch, and target, which means the next epoch. And what happens is that when they are able to decide, let's say there are two epochs happen, and people are able to decide that these two blocks were the checkpoints for, let's say, epoch 1 and epoch 2, then the second checkpoint slot goes into a state called justified, and the previous one, which is on the left hand side, is basically considered as finalized. And let's say after both of these dark green slots, become finalized, which is basically a dark green slot is the finalized one, which is represented here. And when both of them become finalized, all these slots between them also become finalized. That's how it's decided that which block is which slot is finalized, which slot is not finalized based on the checkpoint slots. So we just vote for what is the start and what is the end. And after a few epochs, we can basically figure out that which one was. So we can see that the the first one here is still not completed, but the second two are the one which are completed. These epochs are completed, but still they cannot reach finality because we need two slots ahead which are justified in order for a slot to be finalized. So the final yes one are the ones which are finalized, and if we go to this epoch, we can see finalized yes, and all these slots, individual slots, if we go inside, you can see the status is finalized here. So the same thing won't be true for the blocks which are just produced. And what is the difference between a finalized slot and a non-finalized slot is that a finalized slot has much more guarantee that it won't be reverted. So if your transaction belongs to a slot which is finalized, then you can be rest assured that it's extremely safe because reorg of slots is very difficult for a finalized slot compared to a non-finalized slot. A lot of actors need to act bad in order to change the contents of the final slot. So that was slots and epochs and all of that. But let's talk about the ETH clients. So this is the ETH1 client, which has transaction pool, APM, ETH1 state, and miner, which is basically the logic that calculates the rounds and makes the block valid. And now in proof of stake, this miner was removed and something called execution P2P, which was already there, but that miner part is basically removed and a new client has been introduced, which is like a separate piece of software that validators need to run along with the ETH1 client. And what this comprises of is consensus P2P. So P2P is like basically, let's say it's a group of people talking together, but there are two groups depending on the responsibilities. Consensus is more about deciding what is the correct block, what is the correct slot, what is the correct epoch, all of that. And execution P2P is more like here are the transactions, take it and execute them and check if they are valid or not. And then there's the beacon state, which is on the consensus client. And they both run on the same machine, but they communicate via this engine API, which has also been defined strictly on how they work together and what is the information that should be passed among these clients. And this is like a better picture of how it looks like. So now all the clients basically come with the execution client and the beacon client together, and they talk via engine API, and then there are these Web3 libraries. Based on you use Web3.eth, you can talk to the execution engine, Web3.beacon, you can talk to the beacon node, and both of them have their own P2P networks. And this is the specification of engine API that you can check out on GitHub. It's already out there for people to understand what engine API is, how it works, and what is the information that is supposed to be passed between the clients. These are some implementation of ETH1 clients. Geth is pretty much the most popular one. So it's built in Go, then there is Nethermind, BSU, Aragon, etc. They have their own features and things that make them better. But there is a specification for them as well, execution client specifications. You can check this on GitHub as well, open for all. And you can see what are the rules that need to be, that is mandatory to be followed. Right? You cannot make a client which does not follow the Ethereum execution client specifications, but you can build features on top of it, and the test cases specified here should pass. That's the condition to create an execution client. And this is the ETH2 client implementation. So there is Lighthouse, which is built on Rust. Then there is Lodestar, which is built on TypeScript. Nimbus is built in a language called Nim, and then there is Prism, K2, etc. And there are specifications for these clients as well. So whether to allow withdrawals or not, whether to how to slash, how to reward, etc. All the rules are written here, and the client is supposed to be built in such a way. Then these are node types: light node, full node, archive node. And depending on what type of access you want, you can either access a light node if you just want to like run a node from your phone or something like that. If you want to access transaction details, etc., then you can use full node to do transactions which are very near in the future. Let's say transaction. If you want to access any transaction in the last year, you can get an access to it via full node. However, if you want to run a service like EtherScan or Beacon Chain, then you would probably need an archive node, because people might request information which can be years back, even back to Genesis. So archive node stores everything. Full node stores transactions up to a specific timeline, and light node does not store any transactions. If you ask information about transactions to a light node, it will basically go to a full node and ask for information from it. So how do you become a validator? Right? There is this website called Staking Launchpad by Ethereum Vault. If you go there, there are very detailed steps on how to, like, every step is pretty well defined there and easy enough to follow. So become a validator, and you will need 32 ETH to get started with. That is the barrier that has been introduced to basically improve decentralization and also prevent have civil resistance, so that not everybody can be a validator. A person needs to have a specific amount of ETH, which is 32, in order to be actually called a validator. And this is our timeline. When you deposit, so there's a very specific contract on ETH mainnet which you deposit to when you are following these steps. You send the 32 ETH to this contract, and then when the transaction is confirmed, a receipt is generated and detected by the consensus client. Now this is pretty weird that consensus client detects the transaction rather than the execution client, which is what everybody would expect. But there is an EIP out there which will change this in the future, maybe. And once the receipt is detected by the consensus client, it understands that now I need to add this validator to the activation queue. So you cannot get directly activated to be a validator. It adds you to a queue, and there you will have to wait. And after every 4 epochs, a small amount of validators from the queue are taken and then activated. And we can check this as well. So if let's say go to Beacon Chain, let's see. Okay, I think we can check the figure won't be updated, but you can see pending validators. So right now 68,000 people have waited to be activated, but that's how the validator queue works. After every 4 epochs, a small set of validators will be taken from the queue, and they will be basically be activated, and the consensus client basically stores that information: who is activated, who is waiting, who is exiting, etc. So let's look quickly at what a consensus client will do when it is a block explorer, block proposer. Sorry. So basically, it will receive a notification via the consensus P2P network that now for the next slot you will be the block proposer. So start, collecting transactions and building the block. Once it gets that, it makes the call to via the engine API to ETH1 client that okay, we are going to be the block proposer for the next slot. Let's start collecting transactions. So the execution P2P, which is where all the transactions are being sent to other clients or validators, you could say, will be collected, and then they will basically go into the mempool. So in execution P2P, they will come one by one, and mempool is where they will all be collected. And then they will all go to the EVM where the execution takes place just to make sure that the transaction is actually valid, and then the ETH1 state is calculated. So this is the state difference, which is like before the transaction happened, this was the state, and after the transactions are done, this is the state. And that's how a block is created. And this block is then transferred to the ETH2 client via the engine API again, and it is called execution payload when it reaches there. So we can, if we go to slot this one, we can go to overview and we can see execution payload here. So this is the information about block. Now this is the information which is available on EtherScan. All the other information like aggregation, random reveal, state root is also different on EtherScan, which is not available because this is a beacon chain explorer and EtherScan is more of like a ETH1 explorer or execution client explorer. So once the execution payload is arrived in ETH2 client, then it is transferred to other validators. So because this guy is the block proposer, it will be the first one to create the block and then send it to other people to verify whether this block is actually valid or not. And that's what, again, now once that block goes to other people, now it's the job of the other consensus clients or other validators to receive that block via the consensus P2P. So they are always listening for these blocks from the block proposer. Once it arrives, the same process takes place, but there's small changes. For example, there would be nothing in execution P2P because they were not supposed to collect transactions. There would be transactions in page member, but they would basically be dumped. What will happen is the beacon block will be basically opened up and the transactions will be executed via the EVM. So basically execute all the transactions, make sure the ETH1 state, which is calculated by the block proposer, is still the same that on my machine as well. And if that is the same, then they basically vote that okay, this block is okay and we can go ahead with it. I vote 1 or 0, whatever. And then those votes are basically transferred via the consensus P2P. So I didn't cover a lot of things because a lot of things are taught by themselves. And what are those? Folk choice algorithm. So folk choice is basically, because it's a P2P environment, not everybody knows what is the head of the blockchain, which block is the latest one, what is the, like a lot of things. Even in transactions, nobody knows the order and how do you decide all this. So there's an algorithm called LND Ghost. The full form is very long. But I would encourage everyone here, if you are interested, that go home and learn about this algorithm, how it works, how to select, how do validators decide. Like, imagine like if you are in a circle, there are 100 people talking, and everybody is passing around numbers, and then you have to decide the sequence of those numbers. So it's very difficult how you would arrange those numbers in a sequence, and that's what basically validators do in terms of sequencing slots. Then the finality algorithm as well, on deciding which one is the checkpoint slot, what is the state of that checkpoint slot, whether enough people have voted on that slot to be considered that it is good enough to be not reverted. That is done by Casper FFG. FFG is a friendly finality gadget. You can also check those out. What happened in E2 was the folks who worked on it combined folk choice algorithm and finality algorithm and called it Gasper. So, Ghost Gasper. So you can search Gasper and you will find these algorithms combined. So that's one thing that you can discover. And I didn't talk about how rewards work, how slashing works, and how exiting works. So I would encourage everyone to even explore that. And about beacon data structures. So how does the attestation look like? What does it consist of? How does a slot look like in detail, like every field, what is the type of that field, what is the fields inside those fields, etc. And random, which is the number generation process for dividing validators into committees and then selecting the block proposal, etc., which is also not covered in these slides. So I encourage everyone to like check these things out. If you are interested more in learning about ETH 2.0. And yeah, that's it. If you want to read about today, if you want to follow me, these are the QR codes you can scan. But yeah, I would like to take any questions. I have like 5 minutes. So if you have any questions, feel free to raise your hand and ask. Cool. Okay, I think we don't have any questions, but yeah, thank you for coming in and listening to me. See you. If you have any questions, feel free to approach me. Yeah, thank you.